Hi, welcome to my talk about developing on Windows but deploying on Linux, mostly Kubernetes. My name is Rodrigue Cloutier, Rodrigue, if you want to say it in French, but it's harder for people most of the time. I work for Ubisoft. I'm an online technical lead. I lead a team working on the next generation platform for all our new games. Ubisoft is a company that makes games for people that might not be aware. We've been making games for 30 years now. And our challenge for us is actually we have multiple platforms. So we're working with Microsoft, Sony, Nintendo, Apple for the iOS, Android. We're all the platforms, basically. We're supporting all the platforms. And we have more and more online services. And we want to use open source technologies to make our games better and easier to maintain, because we've been doing a lot of work internally. Now we're trying to get the open source world and integrate the open source world and contribute to that world. But our main crux and our main problem for us is that we're working on Windows games, just like it was said in the keynote yesterday. Fluentd said, well, they want to have Windows support, and it's basically because of us, game developers. All of our games are running on Windows, and we're developing on Windows. Hence this talk. We want to present what we've been doing so far, a bridge between developers working on Windows, but actually deploying Kubernetes. So how can we make it so that people will still work in their environment they're used to, or they have to, but they even go further and try to bridge the Kubernetes community and try to make it work with the tools that we have. The goal of this talk is to share our experience that we had so far. We've been working for about 1.5 years now with this. Give some exposure, what the issues that we had, how we could make it work, what were the problems, and how can we solve those problems, and maybe foster discussion and awareness about the Windows developers. We're out there. There's a lot of people, so we want to make sure that the Kubernetes community is aware of Windows developers. So maybe just start by saying why talk about Windows. The open source world is mainly ruled by the Linux operating system. So most of the people are actually developing open source projects using Linux, using Mac OS for a POSIX base. But if we look at it, and if you take this into account, well, Windows is a second-class citizen. Most of the time, if you take a tool that is open source, you try to run it on Windows, either it doesn't run at all, or it's sort of well, let's try to run it over there, but you might have to do this or that. So we're not treated as a first-class citizen, and we want to try to make it so that we're becoming closer and closer. Why? Well, some people have to work in Windows. A lot of people in the corporate world actually have Windows boxes. They use Windows. It's not an option they have. In our case, it's not even an option. We can't just go and say, oh, let's switch to Linux and it's going to be gone forever. Also, if you look at the Stack Overflow survey, which is not the real picture, but it's a good indication, well, lots of people are using Windows. It's not only that people are all happy saying, oh, Linux is the best OS, or whatever the opinion of people are, is that we do have lots of people that are working on Windows. Now, the trend is sort of changing right now. The next survey that just came out a few days ago is actually stating that people are using Windows and Linux and Mac, and so people are switching between the two, but most of the time you need to go back to Windows if you're working in a corporate world. So what I propose is to have a look at the challenges that we had by trying to address this, then maybe the bridges that we've developed to actually make it work. Now, using those bridges, what are the tools in the Kubernetes community that we can actually use and make it work properly, and maybe some of the action we can take eventually to make it even easier for the next people. So our challenges. In our case, Ubisoft is a big company. We have 29 studios worldwide. We have over 10,000 people working for Ubisoft. Out of these 10,000 people, we have more than 300 online developers. So be it people that are writing online services or consuming online services in their games and stuff like that. So all of these people are basically working essentially in Visual Studio. Visual Studio is the first-class IDE for game development. I don't know any big AAA targeting companies that are not working with Visual Studio. Visual Studio is actually fully supported by Nintendo, by Sony, so it makes it a lot easier for us to actually just work there. So we've been working with that. We've been working for a long time. If you want to develop on the Microsoft Xbox, well, you can't work outside of Visual Studio, so we need to work with that. And it's really convenient for us because if we have everything at one place, we can actually write tools, we can automate, and we've invested a lot in that, so we need to keep working with this. And we have a really, really strong expertise inside Ubisoft. We have lots and lots of tools that are written internally that we can make it and people can use. So we want to keep using those tools and maybe integrate them inside the online workflow. So obviously, for us, it's really hard to do a mass switch to Linux. We can't just go and say, oh, guys, let's go pick up a new box. You're on Linux right now. It's just going to work better. So that's the solution that some people would say, well, just work on Linux. It could work. It doesn't work for us most of the time. So the next step would say, well, let's try to have something that is basically, whoops. Just going to try to bring it back. And maybe have two boxes. Maybe have people working on Windows on one box and then have a second box on the side and say, well, do all your online stuff on the Linux box. We've tried that, not exactly for Linux, but for other stuff. But people are not really happy with two boxes. You need to manage both of the boxes. And then you have context switch. If you have different OSs, it's even worse. Now, your mails are not on one, they're on the other one, and then it gets a lot harder. People are not used to that. And also, we can't really leverage the tools that we have on one side on the other side. So that was a no-go for us. The next one would be to say, well, let's try to run virtual machines inside a Windows box. So that's something that could be done. It's done by some people. But most of the developers that are working on Windows, actually, it's hard for them to just go back and say, well, let's try to run an OS just for the online portions. So that's something that we can't just make it work all the time, although it's a target that we're trying to move forward. But it's still too hard for us, too hard for the programmers. Now, the next step is to say, well, can we have a bridge or something that it will actually be inside your Windows, could use all the technologies that we know in Kubernetes, and just go ahead and say, let's use that and go forward with that. So that's the main topic that we're going to look at is, say, VMs, talk about a bit about VMs, and then talk about the bridge that we've developed because we're working on something where you're still on Windows, but you're using all the tools internally to talk to Kubernetes and all our online stuff. So the thing that we need to be aware of, it can work. It needs some help, and maybe sometime you might want to have a look at what you're actually trying to propose and make sure it doesn't fail. In that case, I think somebody missed something. But it can work, so we're going to make it work. So what are the bridges that we can actually try to target? Virtualization, I just talked about it a bit. So there are several technologies that we can use, VirtualBox, Hyper-V, VMware. That's still something that wasn't tight enough for us. So like I said, it's a bit too far. We might want to use it, but eventually not right now. The other problem that we had is that the tools that we're using Docker, we're using minikube for Kubernetes, they're already running inside a VM. So you can't run Docker natively, even though it says Docker for Windows, it actually runs inside a VM, an Hyper-V. Same thing for Mac. So we have a VM, then if you have multiple VMs, then you start to manage multiple VMs, and people get confused to where is my code living, how do I bridge two VMs together, and then your system becomes more and more complex. And then we don't want to impose that on people. We want to make it as easy as it can be for the game developers. Our team is responsible for the complexity, but they're not the people paying for the complexity. So what we ended up with say, well, how can we make a command shell that would run on Windows to run with the tools? First candidate, the command shell, PowerShell, inside Windows. Obviously, it's there, but it's not a good fit for us. It's not a real bridge. It actually doesn't help you doing lots of things that you want to do, like autocomplete or do stuff like using the default tools. We're still keeping the .bat file support so that some people are actually not using console and they don't want to double click and just go, I want to run this script. So we're using a really thin wrapper for that, but we're not actually coding inside PowerShell or the BAT scripting language, batch. The other part that some people will actually just jump on it and say, oh, let's go ahead, let's go use the Ubuntu shell inside Windows 10. That's a nice option. We've tried it, we looked at it. Our problem right now, but it's moving forward, is that we're not on Windows 10 on the whole company. Obviously, 10,000 people, we're not just moving as the version comes out and say, let's go. It takes a long time to roll, so we're rolling production by production. So it takes a bit of time. Also, the shell that came up with the anniversary edition was actually an older version of Ubuntu. So we couldn't just install all the tools like Docker and stuff like that directly, because we had to go and support a new registry because it was older version. So it was a bit more complex. And the big drawback for us is that actually the anniversary edition cannot call Windows application from within the bash shell. So that defeats the purpose for us to be on Windows, because you're basically sort of running on a poor VM that doesn't have any integration. This seems to be solved with the next edition of Windows that's coming up in April. We'll see, we'll have a look. But still, that's a step where maybe it's still a bit too complex for us, because it's still an OS inside. It's not only a shell. You need to fully manage an OS. You need to know that it is Linux. You need to be aware how Linux works. Now, it might be in the future something we'll address, but right now it's not a short-term gain that we can have. The next ones, for people that are a bit aware of what's going on in the Windows community, try to bridge the Unix tool, there's Cygwin. Cygwin, basically, we've been using it for 10 years or so, but now we've came up with some issues, like the setup is really hard to automate. It's something, I know there are some projects working on that, but it's not natively easy to do. It's a really self-centric view. Cygwin actually doesn't actually say, I want to be a good Windows citizen. It just says, I want to run GNU tools on Windows. And then it's done. So sometimes it just doesn't operate properly with the Windows tools. It doesn't bridge properly. You need to go and do a lot of manipulation for the path to send to an application your proper Windows path, because it's sending Unix path, and it assumes that everybody will consume Unix path. So that led us to the friendly fork of Cygwin, which is called MSys2. MSys2 actually has a really tight integration. The focus of MSys is to actually have a tight integration between Windows and the GNU tools. It's used by Git for Windows. So Git for Windows actually builds on top of MSys to just use all the Linux tooling internally. And also another big gain for us is that there's a package manager, because the older version of MSys, MSys1, didn't have, well, no, it had a package manager, sorry. It's the Git for Windows. You could actually use the bash for Git for Windows internally, and it would actually give you an MSys subsystem. The problem is there's no package manager, so you can't install new packages. So MSys, the native version, will actually allow you to use Pacman as a package manager. And we'll come back to why it's important, because there's a really key issue that we needed to have that. The good news, it works. So we've been using that. It works fine. So there's some tweaks need to do to actually set it up, but it's fairly straightforward. Now, once we have a bridge that actually says, well, we can use native tools and it can use and be closer to Linux, let's look at the tools that we're using and what are the issues that are being encountered while we're trying to run on Windows. First one, Git. Obviously, we came up from the Windows world, so we're using Perforce. We've been using other stuff beforehand. Now we're using Git. Git for Windows works superbly. That's no problem. It works fine. It does provide an MSys2 shell, like I was telling you, so you can actually use Git bash up to a certain point. The issue that we had is that there's an issue being open right now in Git for Windows that it cannot clone. Well, it can clone, but it cannot check out files that have illegal Windows characters. So the colon is an illegal Windows character for a file. You can't not use it for a file name. Now we have something called a Go client SDK that we're using, the Kubernetes Go client, and it has a small vendor called Docker inside there that has a file that has a colon. So we couldn't use actually the Go SDK on Windows if we're not using, if we're using Git for Windows. Now, if you use the MSys2 package manager, you can install the MSys2 Git client, and if you use that client, because it's POSIX based, actually will allow you to use colon files with colon inside Windows. So if we were not to use the MSys2, we can actually build the Go client on Windows right now. So that's why, for us, the package manager was really important. Now, next step, once we have Git, we can actually start using Docker. We've been using Docker for more than a year. It works pretty good. There's no big problem. We're using the VirtualBox version, obviously. We're not using the Windows 10 with Hyper-V because we don't have Windows 10 everywhere. We're starting moving forward. We have it working, but people are not using it right now. We did have some issue, namely with the performance. So we fixed that. I found somewhat why. And now trying to download big images, sometimes it would actually stall or not even download at all. And it was in the network interface issue. So we change the network interface and now it works fine. It might be to our infrastructure. It's something that we noticed. The other thing is that whenever you take snippets from the web, well, nobody actually assumes that you're going to be running on Windows. So everybody's going to say, well, use this and it's going to work. Notably, the mount version from Docker run or stuff like that, you want to do mounts, local mount. Something like this, which actually just mounts your working directory so you can do something on your local directory inside a container, will not work at all if you're actually not doing the proper mounts inside the virtual machine. Now, people get somewhat confused sometimes that the Docker daemon runs inside a VM. It will actually try to mount the directories inside the VM, not your local directory. So you need to mount between a VM and your local directory, do a proper mount. I don't expect you to look at that code and pick it up right now, but we're doing that. So we're doing something on top saying, by the way, just don't only mount, because Docker for Windows only mounts the C users. But if you say, I'm working on a D drive or F drive or whatever, it should actually be there and be available. So we did something for that. That's something to be aware of, because if you take snippet from the web, it actually will never work, and people get confused, and they eventually start working in places where they're not quite sure why. And it works sometimes because you're in C users, but if you're outside, it doesn't work, and you don't know why. Well, that's why. You have to mount your drives. The other thing with VirtualBox, you need to be aware, is it's a POSIX-like file system, and the like part is really important. It actually doesn't enforce the case sensitivity. So you can actually write some files, and we've been bitten by that sometimes, is you can write some files that are not compliant with POSIX, so you have uppercase and lowercase that are mixed, and then you're not using the proper ones, and it would work fine on your VirtualBox, and once you push it on Kubernetes, then start not to work anymore. Then you start to figure out exactly what's happening, and then you find out, oh, well, it didn't help me there. Sometimes it also shadows files, so I've noticed that sometimes, and we don't know exactly, we're still investigating why it does that, but sometimes I would change the files on my file system and then run it on a container. Container doesn't pick it up because the virtual machine actually sort of shadowed the file and it caches it for some reason. And we had several issues with containers that were built on Windows, because we're building the containers directly on Windows. Doing that, Windows doesn't have any notion of permission, file permission, so the permission gets queued sometime, and sometimes it will actually not run, so all the executable flags are not transferred automatically. It could actually make some issues. Also, we had some issues where we're using Scratch containers. Now, it's really nice for Go, whenever you do Go tooling, to use a Scratch container, which makes it really small. If you want to know about that, you can actually ask me afterward or just read it on the net. But the problem is that we found out that Go does cross-compiling, and using a Scratch container actually works fine if you build the image on Windows, but if you run it on Linux, it actually doesn't work. So we're still investigating that. We found out that pretty recently. Now, next step, once we have Docker, well, we want to get closer to Kubernetes. So here we're using minikube. We're a really heavy user of minikube. We have a workflow where we want to iterate really fast, so we do all our work locally, and then eventually we push on the cluster. To us, that's really interesting, because the Windows version is still experimental, but we've been using it for a year now. So we would like to get it out of experimental and say, well, we want to have full support. We did some contribution to the minikube project to help fix some issues with the Hyper-V. I did part of the build system for, well, the makefile for Windows, and we're still working, and we're keeping this on track. There's now an installer, and that's a tiny issue, but the thing is that on Windows, the old sudo curl do something, it's not something that people are aware of that they can actually use, and they will jump on the installer most of the time just really and say, oh, I want to install it, I'm going to try this, and the installer is more safe for people and more in their world. But minikube, other than that, works fine. We don't have any issues. That we're still using it on a daily basis. The next tool that I want to talk about is that we're using Helm, the Kubernetes package manager. For those that not quite know about Helm, it's really helpful, but to us it was a surprise, because we were the first people actually compiling Helm on Windows. So we're like, okay, nice, I can actually do it, that's part of my job. So we did contribute some issues, and then we fixed them, did some contribution to make sure that we actually can create archives on Windows and consume them on Linux, because wasn't the case. The tests weren't running properly on Windows. So we fixed all of that. It works now. The big point was that it was assuming Linux path for everything. So on Windows, the archives that are created could have paths that are not Linux-based. So the / versus /. So the key point about this is to make sure you join the right path. So you use the proper path in Go. So that's Go code. If you do path join, that will actually lead you to the first answer using a URL-based // And if you use file path join, well, that uses the OS file path, which actually leads you to the second answer. So you need to make sure that you use the proper one at the proper place and not assume that everything will be always forward-facing, because on Windows it is not. So be aware of that. Kube Kettle, because we call it Kube Control, so that's the issue of the community. We're using that, obviously. It has good support for Windows. It works fine. We didn't have any big problems. Obviously, we're in a corporate world, so we have a proxy. We have some issues with the proxy, and we have to deal with that all the time. We had some issue with the installer for the Google Cloud SDK. That seems to be fixed so far, but we've sort of moved away from the installer in our case. Now, the other key point, and that's a contribution I did to my first contribution to Kubernetes, the home environment variable, because we're using a bridge that sort of has the notion that it's running GNU tools that are supporting the home environment variable, but we're inside Windows. Well, Go was sort of built to say, oh, no, you're on Windows, don't use home, it doesn't exist. Well, it does exist, and we make it there, and we want to use it, so make sure that we can actually use that. So Kube Control will actually use that now. All the tools that are built on top of the Go client will actually be able to use that. So make sure that we can actually acknowledge that, because we had some issues sometimes, and now fidgeting with the home drive home path on Windows, it's a bit hard. The Go programming language, that's only a slide to say it works superbly nice for tooling. We were really surprised that cross-compiling just works out of the box. So we're working our tools on Windows. We're building most of our controllers or any tools that runs on Kubernetes, actually, we make it run with the Go client on Windows, on our machines, talking to the cluster. So it's outside the cluster. We can actually debug and do all our stuff. And then once it's ready, we just sort of cross-compile it and make it run on the containers, and it runs exactly the same. It runs fine. So that's really, really nice. So that's a really good thing from the Go tool. So again, it works. It's not like everything is not working. It all works. We fixed a lot of the issues, but it's still out there. So we need to make sure that people are aware that it will be there. Now, the action that we can take. So what can we do with the current community to make it so that we don't have next generation of tool to have everybody go through the same process that we're doing right now? So how can we help? Let's take two sides of the equation here. The first one would be as tool consumers. So if you are working on Windows, you want to work and say, well, I have to work on Windows, I have to make my tool chain work properly. Well, the first thing is obviously if there are new tools coming up, well, just ask for Windows support and just say, be vocal about it, be there and say, oh, I'm working on Windows, could we make it work? Could you cross-compile it, please? Could you do something? Then once it's there, give some feedback. If you just say, well, it doesn't work, and then I've asked and I'm done, well, that's probably not good enough. It's not going to make everything go forward. So give some feedback. And if you can, just go ahead and contribute. I've done that, and then people are really welcoming for any contribution, mostly on Windows, because most of the programmers are working on Linux, on Mac OS, and they sometimes don't even have a box to actually test it. So you can become a tester and say, oh, by the way, I've compiled it on Windows. It just doesn't run for this issue. If you can't fix it, at least you've reported an issue. If not, just try to fix it yourself and go forward. Next, if we say, well, the consumer, the other part of the equation is the actually tool builders. So tool builders, if you actually build some tools and you want to open source some tools, and you're not familiar with Windows, or you just say, well, I don't have the resources to do that, well, try to find contributors. Find people that are actually active in your community, active in your issue tracker, and say, oh, I've tested this and that, and try to fetch them and say, well, do you want to become a contributor? That's always a nice carrot to say, well, here, this is maybe a little prize. You can become a contributor if you just push a bit forward. Build and test on Windows. if you write tools using Go or Python, it's fairly easy to actually build on Windows and test on Windows. Also, for open source projects, there's something that people might not be aware of. There's something akin to Travis or Circle CI called AppVeyor, which is a Windows open source free tool chain that you can actually make your stuff run on Windows and test on a Windows machine. So that's something that you might want to take in account. The other part that I touched briefly is a write installer. If you have time, you can actually write installer. We did that. I fixed the installer for minikube so that if you people just come in and they're really Windows-centric and they say, well, I want to try to do this and try to test it, having an installer is really a good entry point. It's easy for people to go back there. Also, if you want to go even further than that and say, well, I think the Windows community is really important and I want to cater to that community, you might want to start writing PowerShell script. That's something that we're working somewhat internally, not a lot, but that's something that people actually consume really readily because that's something where they live in that world, and using bash script for them is something alien a bit. So what we did, we had some challenge. We tried to find a bridge that we actually made it work. The tools are fixed, they're there. We're actually making them work better for our needs in our case. And we might want to have some actions. So it is possible to have a Linux bridge on Windows. The tools are getting better, and it's a lot easier now to actually go and install all that stuff, but maybe we can actually make it a lot even easier than it is right now. And I think that the Kubernetes community needs to be aware that Windows developers are there, and there will be a lot of Windows contributor eventually, because now I didn't talk about that, but I'm not talking about Windows containers, but there's an initiative inside Kubernetes to actually run Windows containers. So eventually we'll have actually people working in Windows running Windows containers inside Kubernetes. So Kubernetes, the community needs to be aware of that and be open to say, well, yeah, we're going to have some different people coming up, but they're nice. We can actually. So this concludes my talk. If you have any experience or people, you want to share some stuff that you've done on your side, or maybe some stuff that I've talked about, if you have any question, I'm open for a question right now. Obviously, this is our experience with our need, our constraint. It doesn't mean that it applies to everybody, but if you can take some bits and parts of that and make it work on your side, that's fine. If you have any stuff that you might want to teach me, I'm also open for that. Thank you. Yep.
I think a couple questions and remarks. Actually, we tried, so we had a similar issue as you. We are running the infrastructure on the containerized environment on Linux, and most of our developers they are working on Windows. Mm-hmm. And we start looking into this how we can onboard them. And we found that it's, you said that you were using
MSys2, yeah.
We found that there is some major issue with things like attachment to the container and running the shell from this MSys32. Especially like the rendering of the screen doesn't work properly like it works on Windows. How do you solve that?
We haven't actually. Well, the question is that sometimes the MSys, even though you're using MSys actually has some different terminals, and if you're using some terminals that connect to a container or do remote execution, let's say you attach using the -ty terminal interactive command on Docker or Kubernetes, actually it doesn't render properly. So sometimes what we notice is that the backspace doesn't work, or the shell, the arrow completion doesn't work. Actually, the rendering sometimes it actually doesn't work at all. You don't see anything. So to us, what we've been doing so far is that we've been trying different terminals. I know that some terminals are better than the other ones, so we need to go and fiddle with those. We haven't actually solved it, and then we didn't say, well, right now it's just good enough for what we're doing, but we're pushing toward production, and we'll see actually if the developers are actually asking for more for that. But obviously that's an issue that if you really want to have a tight integration with the terminal and your your piping.
Running MCs inside the other terminal, right?
Well, no, inside MSys, you actually have terminals that you can use to actually to make sure that you're using a shell inside a terminal. So that's the whole Linux terminology, that you use a terminal and use a shell which is inside a terminal. So your terminal is really important. So if you want to use, I don't remember them on top of my head, but there are different ones, and some of them are better than others. Like I want to use tmux on site in Windows, but I can't use the native terminal from MSys. I need to use another one to make it work properly. Otherwise, the rendering doesn't work. So you need to play around with that and try to figure out which one is good or not.
Another thing that surprisingly, you haven't mentioned the VS Code, which is a great tool from Microsoft.
Mm-hmm.
And it has a Kubernetes support, and
Yeah.
it has a Kubernetes snippet that you can use. So it's actually
Yeah.
Brandon Burns that he wrote the Kubernetes support for the VS Code, and it works just brilliant. You can run VS Code everywhere on Windows, Linux, or Mac OS.
Yep.
And, it's very nice. And you can debug your Kubernetes stuff inside your VS Code IDE.
Yeah, so the remark was that VS Code, the product from Microsoft, is actually a cross-platform IDE editor. With Brandon Burns moving over to Azure, he actually came back and said, how can we make it? So Brandon is working a lot on how can we make it easier for people to work. And he did some integration inside VS Code. So you have some now commands that are directly run. So you don't need to go and run Qcontrol from the shell. You can actually run it from your IDE. The reason why I didn't mention it right now is that we actually don't have anybody using that right now in the company. We have lots of Vim users and other stuff like that, but obviously that's a good point. You can actually go there, and then maybe you don't even need to go to the shell, and you have the tight integration that is just there. In our case, we're still using Go, and Go we use the make files and everything, so we need to have a make that is native. You can use an nmake from Windows, but we use the make from MSys because for us it's actually easier. So that's one of the reasons then using all the different Unix tools is also a plus. But VS Code is a really good, a solid product. Yes?
So for Ubisoft, in terms of migrating from more traditional bare metal environment to VMs and containers, where are you guys at?
Okay.
Middleware, backs, fronts, servers?
Well, I can't obviously go into details with that because I'm not allowed to right now. We're still in flux. So internally in Ubisoft, we do have an internal cloud. So we have a team at Ubisoft dedicated to do internal cloud. We've been using OpenStack, and we have VMware, and we have a lot of stuff. So we're actually pretty solid with that. Now we're actually going to the public cloud to solve the scalability issue, because on our side, we're really good at racking and doing all our stuff. Now, obviously, we can't rack as fast as the users are growing inside a beta launch or something like that. So we're not there. So we started doing a hybrid stuff. Internally, what I can say is that we're working on a kubeception sort of solution. So we want to have multiple clouds. So we're not going to have one Kubernetes cloud for the whole company. Obviously, each production has different needs. So we're probably going to cater for each different games and have different clouds. And we're working on a solution to have on-demand clouds, on-demand clusters for each of our games if they want to have it. So we're working using Kubernetes, the kubeception, so actually using Kubernetes to create Kubernetes clusters. That's something that we're working. So we're sort of fully committed to say we're using Kubernetes. Now, if it will ship or not, that's a different issue, and that's where we're working right now to make it move forward. So we're trying, we have a lot of legacy code that we have legacy platform, and then we ended up saying, well, we're up to a point where investing in that would be more costly than to actually just switch over. So we're switching over and trying to explore different solutions. So we've explored Swarm, Kubernetes, and we're working, and we have several of those working internally at Ubisoft. Not yet, not our team, but other teams are looking at them. So the question was if we're using Windows containers, but obviously we are not, but some other teams are. Yes? Yeah. Okay, the question is if we, what's our CI/CD pipeline? Obviously, in open source, you have Travis, Circle CI, and everything. Right now, we're actually using GitLab. So we have an internal GitLab instance, and we're working, try to solve and try to see if GitLab is a proper fit for us to make sure that we can use the GitLab CI/CD solution in there. So far, it's working pretty good. We don't have lots of issues. The way that we're working with our team right now is that we develop on Windows, but we deploy on Linux. So basically, our CI is all in Linux, so we don't have anything working in Windows. So we're not provisioning Windows machine to develop our tools. So that's why we found out some issues that running our containers locally in our machine works fine on Windows, and then we push it on the CI and it sort of breaks. And you go, oh, why? Okay, well, that's because we're using a full-blown Linux CI solution. Pardon? Yeah, our images are built automatically from the Git push inside a Linux container that is using Docker and Docker to build our solution. Yeah, Windows is only for development. We don't want to have anything that is built on Windows being pushed on the cluster. To us, it's really important that we actually have a full CI/CD pipeline that is built on top of just pushing a commit in Git, and it just works. Yeah. Yeah, it's not because it wasn't working with Windows, because we have other people who actually have a CI on Windows on GitLab. But right now, that's my latest commit that I did just before coming over here, is I'm actually using the Kubernetes runners inside GitLab to make it work so that our runners are actually running on Kubernetes inside our stuff, so that we have a full-blown, we're using Kubernetes as a tool and also developing on Kubernetes, so sort of make it the full circle. Yes, in the back.
So, first of all, I'm sorry I'm not in the game, so perhaps this question is a bit naive. So, could you name, like, I don't know, top 3 tools that you are, like, contributing and you would like them to be super fine working on your setup, and so that you give back to the community as you
Well, right now, we're still developing our pipeline and working on our stuff. What I've presented so far is the tools that we're using on a daily basis. So to us, the minikube, that's why I was saying minikube is experimental in Windows, but obviously to us, it's not experimental, it's production grade, because we're using it so that our developers, we want to make sure that it still works. Helm, to us, is part of our pipeline delivery. So we want to have that working properly and making work fine. And obviously, well, kube control is the tool that we use all the time. So these would be the 3 things. So the question, again, what are the top tools that we would like to see to move forward and make sure that they're upper grade quality? So Helm, minikube, and kube control is namely the 3 main tools that we're using. Now we're still looking at all the other tools around and everything, but anything that touches directly to the cluster is basically almost a no issue, because basically if you talk something like I was looking at Steward, well, that's running on the cluster, so it doesn't make any difference for us, so we're not involved in there. But we're contributing right now to Helm and minikube, so these are the 2 things. We've contributed to the add-on for the local registry, so the registry credential. Minikube has, well, Kubernetes works with a set of credential that needs to be set properly to actually fetch from local registries in Docker. It used to work in a certain way with the old boot to Docker image. Now they've changed the image. Now it wasn't working. Somebody did the contribution, but it was only for Amazon and GKE. We did the contribution to make it work properly inside a local registry. So again, that's another place where people need to be aware that inside a company, we're not exposing all of our image outside all the time. And there's another issue that we're working closely with Google right now, and we're giving feedback, is that basically, if you run a cluster and you have a local registry, well, that's fine. Now, if you want to start pushing on, let's say, a Google registry or Amazon, now your images are sort of built with the Docker. Well, Docker uses an URL. Well, a URL is actually local to my machine or local to my system, which doesn't scale out to the Google Cloud. So how can we solve that to make it so that it's only a convenience that we change on the cluster, saying, oh, by the way, could you change this to that environment variable, something like that? So we're working with them to make sure that this works, but that's a different issue. Oh, thank Thank you. Enjoy your KubeCon.